Teaching mathematics is like constructing a sculpture. It takes a lot of thought and effort to help mold and sculpt a child's brain to think mathematically. Just as no two sculptures are the same, there are no two brains that work in the same exact way. Teachers must be flexible, driven, accommodating, and determined in order for their students to succeed and become the best math scholars possible. Two educational theorists that shape the way I look at teaching math and inform my practice are Piaget and Vygotsky. Piaget's constructivist views align with how I think of learners. Learners construct their own learning through reflective thought. Through building upon background knowledge, students gain understanding and new knowledge. As I worked with the students as they were learning new concepts that built from adding, then multiplying, and then problem solving that incorporated multiplication, it was clear that individuals really do build knowledge based on the information they gain and the knowledge they already possess. This is a profound concept that should influence teachers in the way they pour into students. Piaget suggested that when a new idea does not fit into current understanding, it causes disequilibrium. The students I worked with that were experiencing disequilibrium became quickly frustrated and they were tempted to shut down. It is critical for students to have a strong foundation and be able to build on that foundation. Now, in conjunction with Vygotsky's ideas, I believe that teachers are the facilitators of learning and they are the ones to provide scaffolding in order to encourage the most effective learning. In addition to scaffolding, Vygotsky communicated ideas about students learning best in social, collaborative environments. The students I worked with did an incredible job helping to support each other in the learning process. It is highly important for teachers to facilitate and encourage collaboration. Keeping in mind that the STAR test asks questions that align with the process standards, such as problem solving, communication, and representations, I work to give students the best opportunities possible to refine these skills. Unlike with the content standards, the process standards encourage students to understand how to work through problems rather than just know the formulas and how to calculate the answer to a problem. In order to give students the tools to meet the process standards, I would incorporate group work in every lesson to encourage the students to make their thinking public and communicate to their peers and me how they were looking at a problem. I would give them questions that would make them make real-world connections to what they were learning mathematically. For example, before I taught the students a lesson on angles, I had them explore the different angles within circles and semicircles. This allowed them to see a representation of the ideas I was working to convey and give them the mental tools to problem solve later on as they would work with more difficult questions about angles. Personally, I value testing that incorporates process standards over content standards because it encourages the teacher to equip students to be successful in a world of technology and a society that values creativity and the ability to problem solve. Throughout my time with the students, I began to recognize the value of strong manipulatives. Manipulatives allow the children to learn through exploration and collaboration. The Gallon Man was one of my strongest methods in moving from an abstract concept to a more concrete, because the students were able to compare different sizes of capacity. As I created lesson plans for the 4th grade math students, I refined my ability to create a good objective that would set the tone for the rest of the lesson. Determining the audience and behavior have never been difficult for me, but at the beginning of the semester I found myself struggling to have a solid condition in form of degree of mastery that fit well with the assessment. The reason I struggled with this was that I was not aligning my objective and assessment up together. There was a disconnect. Being aware of this, I began to produce lesson plans in which the TEKS, objective, and assessment all lined up. In producing a strong objective and overall lesson plan, I was able to create an organized procedure to facilitate the best possible development. Through the whole process of lesson planning, I began to consider the worthwhile tasks we had talked about in class. I grew as a teacher in the sense that I began to have various levels of entry and exit points. There was a challenging level of cognitive demand for each lesson, and I began to give stronger and stronger context and relevancies to each lesson. I also grew in my ability to assess the students. In every lesson plan, I included a checklist in order to have a more tangible record of the student's level of understanding. Each checklist I've made became more and more specific, and I began to get more creative in the ways that I assessed. I would assess through asking probing questions and through creative games that encouraged the students to apply their knowledge in real-life ways. On the thought that teaching mathematics is like creating a sculpture, I learned to develop an appreciation for it because just as the final sculpture would be incredibly rewarding, so is seeing the light bulb go off in a child's eyes when he or she finally understands the concepts being worked on.